Hello class, welcome to our last lesson about impulse and momentum. Okay, so before we begin, let us have these objectives for our discussion for today. At the end of the lesson, you should be able to solve impulse and momentum problems, define impact, and identify the different types of impact. Solve problems involving impact, right? So those are the objectives. So from the Newton's second law of motion, so we have here the force equal to the derivative of mass times the velocity. This derivative of mass times the velocity with respect to time. So our force here is a vectorial force as well as our velocity. Okay, so the product of m and vectorial velocity is what we call the linear momentum. Right, so from this expression, we're going to cross multiply both sides. If you are going to multiply both sides by dt or simply cross multiply dt on the left side, so we have the expression f times dt equal to differential of the linear momentum. All right, so integrating both sides. Okay, so integrating both sides, so we have the limit is from t1 to t2. Okay, so on the other side, so when you integrate this one, okay, so we have the limit is from v1 to v2. Okay, so we have, if we are going to integrate this part, so we have the integral of the differential of m times v. Okay, so this is the vectorial velocity. Okay, so the limit here is from v1, no, from v1 to v2. Okay, so this gives us this one is constant, so we have m times v, the limit from v1 to v2. So when you substitute the limit, so you will have m times, substituting the upper limit, v2 or v sub 2, then minus the lower limit is v sub 1, or distributing m, so distribute m, okay, and multiply, so that's why you have it here. Okay, so this expression class, this one, so this is what we call impulse, no? Impulse of force F. All right, so we can rewrite this as impulse. We have impulse from 1 to 2. 1 to 2 is equal to this one, m times v sub 2. So this is a vector minus m times v sub 1. So this is also a vectorial velocity. Okay, so substituting and then transposing this mv1 to the other side. All right, so that's why we have it here. This becomes positive, so this is negative, this becomes positive, plus the impulse, this one, equal to m times velocity, velocity sub 2. Okay, so if you graph this one, you translate this into graph, so we have this representation. We have here mv1 plus the impulse, no, from 1 to 2, which is equivalent to this one, the integral of f dt, equal to this. So the final momentum of the particle can be obtained by adding vectorially its initial momentum, okay, uh, and the impulse of the force during the time interval. So this is the impulse. So this is the initial momentum, okay, and then this is the impulse, and we will get the final momentum, okay. So the dimension of the impulse of a force are force times time. Now this is force times time. We have differential of time here. Units of impulse of a force are Newton second, or this can be written as kilogram meter per second squared times second, or this is equivalent to kilogram Newton per second. All right. So force acting on a particle during a very short time interval that is large enough to cause a significant change in momentum is called impulse force. Okay, so remember this. This is an impulse force. So when impulsive force act on a particle, so we have here mv1 or v sub 1, or the product of the mass times the velocity, vectorial velocity, vector velocity, plus the summation of this impulse force times delta t is equal to the mass times the velocity, vector velocity sub 2. Okay, so we have it here. This expression can be represented as this in our free body diagram. Okay, so when a baseball is struck by a bat, contact occurs over a very or over a short time interval, but force is large enough. Now, it means that even if it's very short time, when the ball hits, when the bat hits the ball, that's a very short time, but force is large enough to change sense of ball motion. Okay, so that is at the impact. So non-impulsive force are forces for which the product, no, the product of this force and delta t, displacement meaning this one, is small and therefore may be neglected. Okay, so that is non-impulsive force. So that's uh, the force when this one is very small, so there's no effect. In other words, there's no impact. Okay, so let us solve a problem similar to what we had earlier, but this time we will solve it using impulse. Okay, but since it's already a long discussion of the intro or introduction or the concept, so I will separate this example into in another video. Okay, so thank you very much. See you on our next video for the example. Bye.